Okay. So in our previous class, we have seen about how wireless communication works, and this is a second topic about mobile application development. And we will begin by discussing some basic concepts behind Android operating system. And then we will move to the second part, which is about practically building mobile responsive applications. Okay. So يعني just لما add, maybe I will add this one. Yeah. So maybe let me ask you some questions related to Android. Okay. So maybe what is Android for you in your case?
It's not like Android is related from Samsung's.
What's Android for you?
It is operating system related to smartphones.
Yeah, because most of the time people get confused in differentiating the Android OS in the form of hardware and software. Yes, so and actually it's the software. Yes, it's operating system for what? Mobile devices. Yeah, it's not only the smartphones, it's also for the smart TVs, smartwatch, and other appliances. Yes. So fundamentally, it was built on top of Linux kernel. So that's a Linux operating system optimized for mobile devices. Because initially Linux was built for what? PCs, yes, for computers. And when we come to that of the computers, most of the time we don't care about the optimization of the hardware, the screen size, and the power related issue, because most of the time we use direct cable to provide a power to the computer devices. But coming to that of mobile devices, we care about the battery, yes, because most of the time we carry them as we go to the office and other places. So we need to have an algorithm or an OS that minimize the resource consumption, which includes both the RAM and also the battery usage of all the application. So that's why Android was optimized in terms of the resource consumption. Okay. And again, the interesting part with Android is it is open source. Yes. So any companies who was involved in manufacturing cell phones and other devices can utilize it for free. And this time, actually, it's owned by Google and owned by OHA, Open Handset Appliances. That's a group of companies working on standardizing Android OS. And actually, this is a typical structure of OHA. So the list of companies involved in the standardization of Android OS, if you count them, nearly around 84 companies are there, which includes mobile operators, software companies, semiconductor companies. So these guys will make standards, yes, which regarding to their security, optimization, resource consumption, and the like. So these are some screenshots of those companies who get involved in standardizing Android OS, even though it is owned by Google at this time, and these guys will create a standard. Just a little history about the Android, how it comes, and actually it was invented by a person named Andy Rabi. This guy, the guy that you see here, and this guy joined Google in 2005, and then he sold his Android Inc. to Google with $50 million at that time. And initially, it was designed to, Android was designed to power this smartphone, that's a sidekick cell phone. So, መጀመሪያ ላይ ለዚህ ነው የተሰራው ማለት ነው. And the initial challenge in building an operating system for mobile devices are the following. The first one is, and phone battery limitation is there, because due to that, they need to work hard to minimize those resource consumption. And the other resource constraint is that of the CPU. The same things goes for limited memory space. And in history, the first Android smartphone that ran Android was this one. This is actually called the one that's called T-Mobile or HTC. This company actually stopped manufacturing the cell phone at this time. And now they are becoming more famous in making virtual reality headset. በጣም ታዋቂ ካምፓኒ ነው ይሄ የታይዋን ካምፓኒ ነው ኤችቲሲ የሚባል መጀመሪያ ላይ ሞባይል የሰሩትም እነሱ ናቸው for the first time the cell phone was invented by HTC but since they are not innovative other companies dominate them and now they move their business sector to the virtual reality headset. And this time this report is actually old. There are nearly 2.5 billion active Android devices. So you can assume how much business they have. Yes, they are almost 80% of the smartphones currently they are powered by Android. Of course, we do have different types of OS for mobile devices. Yeah, if you take more closer look again, you are very familiar with this logo or that was. Yeah, so maybe we can share with them later on. Yeah. So this is the logo of the Android. And actually it was developed by Irina Block at Google in 2014. And the idea comes from, if you know these pictures most of the time, when we go to the bathroom, you can see this symbol, yes? So she was motivated by that, and she came up with some sort of robot and some sticky person here, and this became the dominant icon for the Android. Yes, so every time Android or OHA release a new version of Android operating systems, and most of the time they name it like Cupcake, Donut, Eclair, Froyo, Gingerbread. Actually, the name is alphabetically sorted. If you take a look at those later, C, D, E, F, G, H, I, S. So almost sorted. Yes. So it works like that. And now we have Android 10. And the question is very clear: why we need to upgrade our operating system? Why? Why they release a new version? Yes. Why do we need to have a new version of Android operating system or any other software? Because softwares are made by us, yes, by the human being, yes. So we can't perfect everything when we build something. So error typos may come up, yes. So every time they will care about the security, they will optimize the resource utilization, and they work on the graphical user interface. So we need to update to the latest version from 3 perspectives: resource utilization, graphical user interface, and security. Those are those 3 things that we need to remember in updating any kind of software. So this is a typical structure of Android operating systems. That is they use a layered approach, and at the beginning, I already mentioned that Android was built on top of Linux kernel. Yes, Linux kernel that's optimized for mobile devices. So those Linux kernel are responsible for handling the hardware-related issues, like supporting device drivers, camera, and the numerous things. So those are built-in libraries. And on top of that, we do have some sort of library that do some special purposes, like OpenGL for graphics purpose, Open Graphics Library, we do have that. And to support some database-related tasks, we do have the lightest version of the smallest version of SQL. That's also called SQL Lite, very, very tiny SQL for mobile device. So you can use your mobile as a database and you can store anything on top of that. And we do have SSL too for that's a secure socket layer, and numerous libraries are there. And again, we do have Android runtime. So this will act like a middleware between your application and the Linux kernel. Yes. So you can consider this one as like a Java virtual machine, as we do when we write the Java code. Yes. So this will do the same thing as that of the Java virtual machine, but we call it a Delphic virtual machine. Because when we compile a Java code, it will be translated into a Delphic code. That's why it gets this name. And at the top, we do have application framework, and we can build different types of application when we write Android code. Our application can be an activity, something that has a graphical user interface, or a background service. Like for example, we don't have an interface for receiving a call. Yes, can you figure out where that things comes when somebody calls you? Some user interface will pop up. Yes, can you see that graphical user interface without receiving any call? We can't see that. Yes, yeah. So those things are called background services. Okay, so we do have some sort of framework that will ease the way we develop an application for mobile devices. So those are called application framework. So at the top, we have applications that we built using these sort of frameworks. That can be an activity manager, window manager, content provider. This is actually, this library allows us to exchange the data between applications. For example, if you want to do an application that needs to have an access to your contact, you can use a content provider. Through content provider, you will have an access to the database of another activity or another application. So you don't need to recreate it again. That will be done with the help of content provider. And we do have an application or a framework that supports notifications. Like when you receive an SMS, notification manager will pop up that. So in short, Android OS use a layered approach. Yes, so when you build an application, you don't need to utilize all these resources because cell phones are resource constraints. Yes, so that's why everything is separated. If you want to build an activity or something that has a graphical user interface, just you need to utilize this one. And if you are going to build a notification, use this one. If you are going to use something that requires a location manager that uses GPS, something like that, you can use this one. Telephone managers, and if you want to do some phone call or you want to do something that's related to that. So that's the core part of Android OS. And actually, the detail will be provided later on. You can read and try to figure out the detailed description of each layers, and I will share the resource later with you. So since I already mentioned all those components, I'm going to skip this part. And the thing I'm interested to discuss here is about the Android runtime. So as you can see from the slide, when we compile an Android, we will utilize a Delphic virtual machine. So each application will run in its own virtual environment. So that directly means all applications are isolated. So when you launch one app, let's say it's contact, it will utilize its own virtual memory space. So this memory interface will not interfere with another app you are currently running. Yes, yeah, and so this is a typical compilation strategy. So you may utilize some ID, integrated development environment. In our class, we are going to use Android Studio. Then you can utilize that, and you can write a Java code or an XML file. And when you compile it, it will be compiled into class similar to that of Java code. And then using the compiler, it will become .ex, Delphic virtual machine. And finally, we'll have a machine code that can be easily executed by the Linux OS. So I already mentioned about this one, and just skipping, and importantly, we need to care about the memory utilization when writing an Android code, okay? So yeah, of course, there are some design concerns when we deal with when we are building an application for mobile device, because mobile device comes with what? Different screen size, different resolutions are there. Yes. So the key question here is how to support different screen size and orientation. Yes. So if you don't consider these kind of issues, maybe you only consider the portrait one, and if the user rotate the screen, you may come up with some ugly GUI for your application. So you need to consider both. What is the lookup of your application when you put it in portrait mode? How about the rotation? How about different screen size? So the things that you are going to build must run on every device. And you need to convince the user that that application was built for their specific machine. ይሄ ማለት ምንድን ነው? አንድ አፕሊኬሽን እኔ እዚህ ላይ ጭኜ ራን ሲያደርግ ክት ብሎ ስክሪኑን ሞልቶ መታየት አለበት። ለዚህ እንደተሰራ ተደርጎ ማለት ነው ፐርፖዝ። ያንኑ አፕ ደግሞ ታብሌት ላይ ኢንስቶል ሲያደርግ ለታብሌት የተሰራ መምሰል አለበት። ያንን ኮንሲደር ማድረግ አለብን ማለት ነው። Of course, we do have some strategy to do that. It's not such difficult. Anyways, we need to consider this one. If we install that app on a smartwatch, it needs to consider the size of that screen or that watch. Similarly for this one for PC. So in short, it needs to be responsive. Okay. So of course we do have different screen size, and we need to consider that even resolution is also very different. Yes. በጣም ውድ የሆኑ ሞባይሎች በጣም ሬዞሉሽናቸው high ነው. We need to consider that. Okay. So this is a key takeaway. Give every user the impression that the app was designed specifically for their users' devices. They need to feel it like that. Okay. And of course, for the security purpose, the Android provides two types of security most of the time. So the first one is they will ask the users to give a permission to that specific app. That's the strategy that the Google used to transfer this risk from its company to yourself. ስንጭን ኢንስቶል ስናደርግ ይሄ አፕ ይሄን ስቶሬጅ አክሰስ ያደርጋል፣ ይሄን ያደርጋል ብሎ ይነግረናል። ኦኬ ብለህ አክሰፕት ካደረግ በኋላ ጎግልን መክሰሳችንን ማለት ነው። Because you already gave a permission for that specific app to use your device, to have the access to your smartphone SIM card or external storage devices. So Android provides different types of security. So that's why you can say individual controls, device security, resource must be explicitly given to the app. You need to code that by yourself. And actually, the interesting part, recently, Google announced that you need to ask a permission. So you need to declare what kind of resource you are going to utilize to run that specific app. For example, if you are building an app that supports Ethio Telecom, like for filling the voucher card or purchasing the package, directly you are going to access the SIM card. So in writing your code, you need to declare that your app requires those resource facts. So if you declare it when the user tries to install his app, that app on his machine, Android will ask the user to give a permission or deny that. So that's why you can see the control is up to the user. Okay. So yeah, like this one. Most of the time, if you want to install an app, most of the time simply say accept, agree, something. We will do it like that. We don't care about the security. Sometimes those flash apps that you download from the Google Drive, it may ask you to give a permission for him to reach the SIM card or memory card. Yes. በጣም አንዳንድ ገራሚ አፖች ፍላሽ ነው የሚያበራው። ስራው ፍላሽ ማብራት ነው። just to open the flash. ግን ስጭኑ ብዙ ነገር ነው የሚጠይቀው። ስለዚህ ያ ችግር አለበት ማለት ነው። No way. Yes, there is no relationship between opening the flash and accessing the cell phone storage. You need to care about that. So that's the thing. And yeah, of course, in building an application, this is the diagram about how you are going to ask the permission. So first, you need to declare that what kind of permission does your application requires. Specifically, you need to do this one in manifest file. And then you need to specify, is it the runtime permission or not? If yes, you need to request the user grant, user has to accept that. If you know, no further action is needed, so the app is going to be installed on that specific machine. Actually, we can ask a permission like this. You need to write this sort of code in your Android manifest file like this one. So you need to say use permission, then you need to say android.permission.write external storage. That means your ASCII is going to write something on the external storage, maybe taking a picture of picture. So after taking a picture, you need to store that JPEG or PNG file on your memory. So you need to request for that permission. Yes. Yeah, you need to declare each permission that your application requires inside Android manifest file. So these are the different way to ask a permission. For example, if your app requires the internet connection, you need to give this permission. And even that of the Wi-Fi, call phone, camera, you need to declare it like this. So this is the basic concept. And maybe I will stop this one and we can move to the next part.